bending world of quantum mechanics, where consciousness might just be the creator of reality. We're diving into the deep end of the scientific pool, exploring the enigmatic relationship between quantum mechanics and consciousness. This is a realm where the tiny particles that make up our universe exist in multiple states at once, a phenomenon known as quantum superposition. But here's where it gets really interesting. Some theorists propose that it's our conscious minds that collapse these multiple possibilities into a single reality. Imagine that. Our minds, merely by observing, might have the power to shape reality. It's an idea that challenges our most basic assumptions about the world and our place in it. This is the world of quantum mechanics, a realm where consciousness might be more than just a passive observer. Useeit, quantum mechanics, born in the early 20th century, revolutionized our understanding of the universe. Let's take a brief journey through time to appreciate how this radical shift in perspective came about. In the dawn of the 20th century, the world of physics was in turmoil. The classical view of the universe, a well-oiled machine operating under Newtonian laws, was under siege. Two men, Max Planck and Albert Einstein, were at the forefront of this upheaval. Max Planck, a German physicist, was grappling with a puzzle known as the black-body radiation problem. To solve it, he proposed a radical idea. Energy, instead of flowing smoothly like water, comes in discrete packets he called quanta. This was the birth of the quantum theory. Albert Einstein, a name synonymous with genius, took Planck's idea and applied it to light, suggesting that light was not a continuous wave, but a stream of particles which he called photons. This idea, while controversial, earned him the Nobel Prize in Physics in 1921. The quantum revolution didn't stop there. It delved deeper into the subatomic world, revealing phenomena so bizarre they defied common sense. Quantum superposition, for instance, proposed that a particle could exist in multiple states at once, only settling into one when observed. Quantum entanglement, another strange phenomenon, suggested that two particles could become entangled, such that the state of one instantaneously affects the other, regardless of the distance separating them. These discoveries challenged the very fabric of our understanding. They suggested a universe far removed from the predictable clockwork world of Newton. Instead, we found a universe that thrived on uncertainty, where the observer played a crucial role, and where entangled particles defied the limits of space and time. Quantum mechanics thus presented a new reality, one that was strange, yet intriguing. It was a reality that didn't just observe the universe, but actively participated in shaping it. It was, and continues to be, a tantalizing glimpse into the fundamental nature of reality itself. Quantum mechanics paints a picture of reality that is starkly different from our everyday experiences. Dive into the quantum realm, and you'll find a world that defies our classical understanding of space, time, and causality. One of the most striking features of this realm is a phenomenon known as quantum entanglement. This is where two particles, no matter how far apart, can instantly affect each other's state. If you change the spin of one particle, the other changes too, instantaneously. This spooky action at a distance, as Einstein called it, challenges our notions of space and time. It suggests that at a quantum level, space and time may not exist in the way we understand them. Now let's talk about the famous double-slit experiment, a cornerstone of quantum mechanics. If you're not familiar, here's a quick rundown. When particles like electrons or photons are fired at a barrier with two slits, they don't just go through one slit or the other as you might expect. Instead, they behave as though they're going through both slits at the same time, creating an interference pattern on the other side. But here's the kicker. If we attempt to observe which slit the particle goes through, it behaves differently. It goes through one slit or the other, not both. This experiment has been interpreted as evidence that the act of observation affects the outcome, a concept known as wave function collapse. What's fascinating about these quantum phenomena is that they don't align with our everyday experiences. In our macro world, things have definite locations and properties. They don't exist in multiple states at once or affect each other instantaneously over vast distances. These quantum quirks challenge our fundamental understanding of reality. Are these phenomena telling us that reality is not as fixed or objective as we once thought? Could it be that the reality we experience is just a subset of a much stranger quantum reality? Quantum mechanics, hence, challenges us to rethink our understanding of reality. Could our minds, through the lens of quantum mechanics, be more than just observers of reality? This question launches us into a fascinating exploration that lies at the intersection of consciousness and quantum mechanics. There are theories suggesting a relationship between the two, sparking profound debates and discussions among scientists, philosophers, and thinkers worldwide. Let's delve into the concept of the observer effect. In the world of quantum physics, this phenomenon refers to changes that the act of observation makes on the phenomenon being observed. It's like the mere act of watching affects the observed reality. This is where quantum mechanics takes an interesting twist, bringing consciousness into the picture. The observer effect has been a topic of heated debate among physicists. Some believe that the act of measurement by a conscious observer collapses the quantum wave function, a mathematical representation of all possible states of a quantum system, into a single state. This suggests that consciousness plays a direct role in the outcome of physical events. This interpretation, however, is not universally accepted. Critics argue that the observer effect is misinterpreted, and it's not necessary for the observer to be conscious. They propose that any interaction with the environment can cause the collapse of the quantum wave function, not just conscious observation. Nonetheless, the idea that consciousness and quantum mechanics are intertwined has given rise to the quantum mind hypothesis. Proponents of this hypothesis argue that quantum phenomena could be the key to explaining consciousness itself, possibly suggesting that our minds have quantum computational capabilities. This view has led some to propose that our consciousness in the quantum realm could be a creator, not just an observer. It's a mind-bending proposition, one that challenges our understanding of reality and our place in it. But it's also a testament to the endless possibilities that quantum mechanics unveils, encouraging us to look beyond the obvious and question the very nature of our existence. Our consciousness in the quantum realm could be a creator, not just an observer. Quantum consciousness remains a fascinating yet uncharted territory. It's a term that's been thrown around in scientific circles, and yet its exact meaning and implications remain elusive. The concept of quantum consciousness is a daring proposition. It's a hypothesis that our consciousness, the very essence of our being, is not just an emergent property of complex computations in the brain, but may indeed be a quantum mechanical phenomenon. The current state of research is a mixed bag. Some researchers argue with conviction that quantum phenomena play a crucial role in the workings of the mind, while others dismiss this as fanciful thinking. The main challenge lies in the fact that the human brain, warm and wet as it is, seems an unlikely place for delicate quantum states to survive. Yet the theory persists. The controversial theory of quantum mind proposes that consciousness is a product of quantum processes within the brain's neurons. Proponents such as Roger Penrose and Stuart Hameroff suggest that quantum vibrations within microtubules in the brain are the key to understanding consciousness. However, these theories face stiff opposition from traditional neuroscientists who argue that the brain is simply too noisy for quantum mechanics to have any effect. The jury is still out, and the debates continue. Yet the possibility that our consciousness may be influencing the reality around us is too tantalizing to ignore. If we were to accept the quantum consciousness theory, it would not only change our understanding of the mind, but also of reality itself. Imagine a world where our conscious thoughts and intentions could potentially influence the very fabric of reality. It would be a world where science meets philosophy, a world where the observer and the observed are one. This is the enigma of quantum consciousness. It's a journey into the unknown, a leap into the realms of the unfathomable. It's a quest for answers that may well change our perception of existence itself. Quantum consciousness, thus, represents a frontier where science and philosophy intertwine. As we delve deeper into the quantum realm, we find ourselves questioning the very nature of reality. This journey has led us through the enigmatic birth of quantum mechanics, where particles exist in multiple states simultaneously until observed. We've navigated the complex relationship between quantum mechanics and reality, where the act of observation collapses the wave function, solidifying reality as we know it. We've pondered the fascinating concept of the quantum mind, exploring the possibility that our consciousness could be a participant in creating reality, not just a passive observer. We've ventured into the realm of quantum consciousness, a territory yet to be fully explored, where the line between observer and the observed blurs, hinting at a profound connection between consciousness and the universe. As we continue to explore this quantum world, we leave you with a thought-provoking question. If consciousness creates reality, what does that say about the nature of our universe?